Hello guys, and welcome to this video everyone. Have one of you or any one of you have some sort of emergency lights like this one? Mine is called a CamiSafe type. There are other types like the Lonto and other companies who create different forms of flashlight in different formats. Well, this one is a bit stylish, which I've got. It's got some batteries and some power circuits in it. It helps in case there are some form of power outage which you need some light source immediately. Now in this video I'm just going to open it up, then we'll talk about the internal circuit and everything that makes this torch a glory. So let's get to it. Wow, here's some pretty basic circuit we've got in here. A lead acid battery, board, and a wire going to the LED circuit. So this is virtually everything on the board. Simple circuit, but we shall go into details later. This is beneath the printed circuit board. Firstly, we shall start with the battery because this lamp is kind of damaged. If you charge it on some time and you're using it, it just lows very fast. It goes low. So first of all, I'm gonna desolder the battery from the unit. Okay, this is the battery. Now let's take a voltage reading of the battery to see its condition right now. Oh, okay, the battery is 3.4 now, but I'm guessing that once it has been connected to the LED, it drops very drastically, which is unfortunate for it. Maybe it's close to the end of life. Now this is the circuit on the board. It comprises of a switch, a capacitor, two resistors for limiting current to the LED. Then we have one resistor close to the capacitor and also one resistor to limit current going to the red LED. So let me reverse engineer everything as seen here. This is basically how everything is wired in the lamp when I reverse engineered it. This is the mains input voltage. This is the current stepping down capacitor, which is in series with the mains voltage, a resistor, then a bridge rectifier, a red LED for indicating that charging is going on in the circuit. This is the battery that is connected in the circuit being charged, and this is the switch, which is a single pole double throw switch with two resistors at the two poles, which is connected to the LED panel. This is basically everything you will see. So now let's go step by step. This is the mains voltage. Now this capacitor is a 1UF 400 volt capacitor. This volume of capacitor is chosen so that it can withstand the spikes of the mains voltage, because the mains voltage spikes could go as high as 400 volts. So to limit or make sure that the circuit is a little bit safe, the capacitor is chosen at that high surge rate. Now you'll be wondering why this resistor is here. It is here to discharge the capacitor as soon as mains voltage is removed, because this capacitor has an ability to save the high voltage current coming from the mains, which should shock someone in case you touch the capacitor while the whole system is open. So this resistor value makes sure that the whole spike is grounded, like is destroyed at once when the mains voltage is out. Now this is the bridge rectifier, who takes in the mains voltage across this capacitor. Well, necessarily the capacitor doesn't bring down the voltage of the mains. It only brings down the current because of its reactance. So if you have 220 volt appearing at this place, and after this place you will still get a 220 output. Now this voltage goes to the bridge rectifier, and due to electrical characteristics, the output can go as high as 310 to 20 volts, which goes to the battery. Now, due to the very limited current that this circuit can provide, once the battery starts drawing current, the voltage drops drastically, almost to the same voltage as the battery, which the battery can tolerate as far as it is connected when the whole circuit is plugged into mains. This capacitor is used based on the current the battery will draw. Now, for every microfarad capacitor that is placed in this part of the circuit, we will get approximately 50 mA of current at the output. 50 mA of current. If a 2 microfarad capacitor placed across this place, we will get 100 milliamps current flowing out of the bridge rectifier. But this capacitor is used maybe to charge the lead acid battery in a slow manner. So this is connected to a switch and to 2 poles, which when close to the first pole, it goes over to the 5.1 ohms resistor, which makes the LED panel to shine dimly. But when it goes further to the other pole, it goes over to the 0.62 ohms resistor, which makes the LED to draw very high current and thereby shine brighter. Now this indicator LED is connected in such a way that in case the bridge rectifier fails in operating, the red light will not turn on when plugged to mains. This is a good way of connecting this indicator LED so that we know when a component is faulty and be able to replace it as soon as possible. Well, this is basically how the whole internal circuit of this lamp works, and it is very little because you do not have to touch the switch or any contact opening of the LED panel when it is plugged to mains, because the mains voltage is unisolated and can still go across these terminals. Yes, it can still go across this terminal. So, and it is advisable not to turn on the LED panel or turn on the unit when it is plugged to mains, because it could fry out the LED panel. So always be cautious when plugging this type of LED emergency lamp into the mains voltage, because you won't be able to turn on the LED panel as far as the battery is being charged in the mains. You only turn on the LED panel when it is out of mains voltage. So this is basically everything you need to know about this kind of LED panel. Once you open them up, you'll be able to identify what and what are operating inside the panel. Well, in my next video, I'm going to be modifying these lights and switching off the battery to lithium, switching the whole charging system to ensure better efficiency of the light. Thank you for watching this video, and see you next time.